Well, students, we now come to the topic of conservation of momentum and collision. Now, as you know from Newton's third law, we can go on to write that F1 is equal and opposite to the force F2, which is the reaction force. Now, this means they are equal and opposite. Now, as we go on to write this whole thing, we can put it in the differential form of dp1 dt, that is equal to minus of dp2 dt. And then we can go on to write that ddt of p1 plus p2, obviously with a vector sign here, with a vector sign here, with a vector sign here, p1 plus p2, we can go on to write that this is equal to 0. Now, the moment we take p1 plus p2 ddt of p1 plus p2 equal to 0, that eventually gives us the aspect that hence p1 plus p2 is a constant. Now, as we show that p1 plus p2 is a constant, we say that this is nothing but the conservation of momentum. Now, students, we need to understand that how this conservation was applied by Newton on collision of bodies. Newton tested this whole thing on a billiard table with billiard balls. And what he suggested was that if these are the balls of having mass m1 and m2, and if they have an initial velocity of u1 and u2, and as you can see that before collision they should have a condition of u1 greater than u2, because it's very simple that if u1 is not greater than u2, then they are simply not colliding. And after collision, the balls are separating, and they are separating with velocities again that of v1 and v2. Now, these two velocities, v1 and v2, I hope you understand that for separation, again, v1 should be greater than v2, because otherwise the separation will not take place and they will collide again. In fact, there is a question framed in this way that will the balls collide again? So in that case, you have to show that v2 is greater than v1, and then only the balls will collide again. Now, on the basis of this direction of the moving of the balls, Newton wrote the conservation of linear momentum as mu1 u1 plus mu2 u2 is equal to m1 v1 plus m2 v2. So this was the conservation of momentum as applicable to these colliding bodies. Well, now the question arises that what will happen if the ball moves in opposite direction. Say for example, what will happen if the ball is directed like this and then like this, and then if the balls move towards each other, say like this v1 and like this v2. Now, I will just change this value of v2 here. This is actually v1 and this is actually v2. So you can see this direction of v1 is just opposite to this v1. So again, this should be put with a minus sign here, as we have put this with a minus sign here, as the direction is not same as the previous value of u2. So in this particular directional case, we should write the momentum equation as m1 u1 minus m2 u2 is equal to minus m1 v1 plus m2 v2. So I hope you got the thing right, that this is how we should put the equations. I will give you one more example to make you understand that how we are going to take the sign. Say for example, the two particles are moving in this direction, both in the same direction, and after collision, both of them start moving in the same direction with the same velocity. Well, with that case, say this is m1 and this is m2. So for that case, what we should do is we should put m1 u1 plus m2 u2, and then we should put m1 plus m2 into v. Now, if they are moving in this direction, say this is u1, this is u2, and after collision, both of them move towards the same direction, say with velocities v1 and v2. Now, what we should write the sign? We should put it as m1 u1 minus m2 u2, And as these two signs are both positive in sense, that is in accordance with the mother equation, we should put them as m1 v1 plus m2 v2. So this is what we should do with the collision as accordance with Newton's laws of conservation of momentum. Thank you, students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.